Welcome to the last video of Chapter 11, which is Use Geometric Probability. This may seem kind of out of left field probability, but today's probability is all about area. So basically we're going to be calculating areas and then finding probabilities based off of those areas. Now, I'm very sorry to tell you this, but unfortunately the 11.7 notes did not make it into your packet. I don't know what happened, small mistake, I am very sorry, so you're going to have to take notes on a separate sheet of paper. Maybe you have a notebook or just a piece of loose leaf paper. So I'm really sorry about that, but please be understanding. And I will not make this mistake again. So let's look at what exactly are we learning today. We're going to calculate geometric probabilities two different ways. One, using a number line, and then second one, using a geometric figure. Number line should be super easy. Geometric figure is when we're actually going to do area. With calculating probability using a number line. So we should probably talk about what is probability. I don't think you all have ever learned probability before, so this is going to be something new. The probability of an event is a measure of the likelihood that the event will occur. So probability is always a number between 0 and 1. It's expressed as a fraction, a decimal, or a percent. Today, we're going to be using fractions to show probability. I forgot to mention, because you do not have this in your packet, at times you might need to pause the video so that you have a chance to write everything down. So please do that. So let's look at what do probabilities look like. So here's a figure. I said probability was always between 0 and 1. If the probability of an event is 0, it means that the event is impossible. It's not going to happen. On the other end, if the probability is 1, it means that the event is certain. So the closer that our probability is to 1, the more likely it is to occur. The closer it is to 0 means it's not very likely to occur. So for example, the probability of an event is 0.25, it's not very likely to occur. That's pretty close to 0. If the probability is 0.75, it's pretty likely. That's close to 1. If the probability is 0.5, it's equally likely to occur or not occur. It's halfway between 0 and 1. Okay, so let's just jump into some examples. Here's example number 1. It says, find the probability that a point chosen at random on PQ is on RS. So I'm going to give you a general idea of probability. So the general form of probability, I said it's already a fraction, and the numerator, it's what we're interested in. In the denominator, it's the total. So in our case, we're interested in a point chosen at random that's on PQ is on RS. This is the part that we're interested in. We want to know what's the probability that it's on RS, given the total is PQ. So a point on PQ that's on the total, we want to know what's the probability that it's on RS. Okay, so looking at our figure, RS is here. It goes from -2 to 4. Hopefully we know that that's 6 units long. Now our total is PQ, -5 to +5, which is 10. So this probability is going to be 6 out of 10. Simplifying that, that's 3/5, or 0.6. So that's the probability that a point chosen at random on PQ, so out of all those points on PQ, that it also happens to be on RS. So again, probability is what we're interested in over the total. We're interested in RS, our total segment is PQ. So let's look at another example. Here are the two that I would like you to try. So find the probability that a point chosen at random on PQ is on the given segment. Express your answer as a fraction, decimal, and a percent. So PQ in this case is still our total, and then these two are what we're interested in. So you need to express these as a fraction, decimal, and a percent. So if you would be so kind as to pause the video and try these two on your own, please. Come back after you have finished, just like normal. Good luck. Okay, so let's see how we did. This probability, RT, that's what we're interested in, and then our total is still PQ. Now, RT is just one segment long. It goes from -2 to -1. PQ is still 10. It goes from -5 to +5. That's a difference of 10. So the probability that a point chosen at random is on RT is 1 over 10. That's a fraction. As a decimal, that's 0.1, which is 10%. So all three of these answers express the probability. Now for TS is this one right here. It's -1 to 4. That's 5 units long. The total PQ is still 10. Simplifying, this is 1/2. 1/2 as a decimal is 0.5, which is going to be 50%. So the probability that a point is on TS is 50%. Now looking at our two probabilities, 0.1 versus 0.5, 0.1 is close to 0. So that means that this event is pretty unlikely. So given PQ, this entire segment, the probability that a point is on RT is going to be pretty unlikely. RT is a very small portion of that entire number line. Now, on the other hand, looking at TS, 0.5. This is likely or unlikely. It's in between. If we look at our entire segment PQ, the probability of being on TS, it's about equally likely as it is unlikely. It's definitely a much bigger segment than RT was, which is why the probability is so much bigger. So that was the number line. That was calculating probability using a number line. Now we're going to calculate probability using a geometric figure. It's going to use a similar idea. We're also going to introduce some area, and it's going to be a little more difficult. So let's move on to an example. Example number 4, it says calculate the probability that a randomly chosen point in the figure falls in the shaded region. Okay, so probability, I told you, is what you're interested in over the total. We're interested in falling in the shaded region. So our probability in this case is going to be whatever the shaded region is over the total region. So the total is generally easier to find. So we're going to find the total. The total area in this case is this figure right here. So the total is a rectangle. Now remember, to find the area of a rectangle, it's going to be base times height. The base is 10 and the height is 70. So our total, the height is 7. Jumping ahead of myself. 10 multiplied by 7 is going to be 70. So our total area is going to be 70 units, whatever these units are. Now the shaded portion is a little more difficult to find. That's going to be the rectangle. But then I'm going to have to subtract this semicircle. And I'm going to have to subtract this little rectangle. Our total rectangle, our big rectangle is 70. We already calculated that. Then we have to find the area of a semicircle. Remember that a semicircle is pi r squared. Well, that's the area of a whole circle, but we need to multiply by a half since we only have half a circle. So that's going to be 1/2 pi, and then I need to think, what is my radius? Well, looking at our figure, the radius goes center to outside. 10 is the diameter, so our radius is 5. It's going to be 5 squared. And then I need to calculate the area of the little rectangle. Little rectangle is base times height. The base is 10. The height is a little trickier in this case to find. So this is the height that I'm interested in. I know the entire side is 7. Well, I need to think. The radius of the circle is 5. If the entire side is 7, then this little height of the rectangle is 2. Okay, so let's say that again. The entire height of the rectangle is 7. The radius of the semicircle is 5, which leaves 2 as the height of the little rectangle. So now let's do some simplifying. This ends up being 70 minus 5 squared is 25. If I multiply 25 by 1/2, I get 12.5 pi. And then 10 times 2 is 20. Now 70 subtract 20 is 50. So 50 minus 12.5 pi, this is our shaded. Okay, now going on to probability. Our probability is the shaded portion, which is 50 minus 12.5 pi, all over the total, which is 70. Okay, I know that this does not look very nice, but that is our final answer. That is the probability. Now, I told you that probability is between 0 and 1. I don't know about you, but I look at this fraction and I have no idea what that equals. So I'm going to suggest that you right now plug this into your calculator and see what this turns out to be. One word of warning when you're putting this into the calculator, you need to make sure that you keep that numerator in parentheses. So make sure the numerator is in parentheses. It's probably a good idea just to put the denominator in parentheses also. So I did this for you, and I got a probability of 0.153. Okay, so I always like to ask myself, does this make sense? First of all, the answer is between 0 and 1, so that's a good sign. Now I need to look at my figure. A probability of 0.153 means that the shaded region is about 15% of the total region. Does that look like it might be the case here? Well, yes, the shaded region is a very small proportion of the entire figure. So this probability looks to be about right. Now again, I know that your answer does not look very nice, but I need both of these answers. Top answer is going to be your exact answer. It has the pi in it. The bottom answer, the decimal, is going to be your approximate answer. The approximate answer is the one that you're going to use to check, does my answer make sense? Okay, so I know your head might be spinning a little bit right now because that problem was difficult, but that's okay. We're going to go on and do one more together, and then you're going to do one on your own. So let's move on. Here's our next example. It says calculate the probability that a randomly chosen point in the figure falls in the shaded region. So again, your probability is going to be what I'm interested in, the shaded region, over my total. Okay, so the easiest is the total. The total figure in this case is just a circle. I neglected to mention this on the last example, but your total region does include the shaded part. So we do include that shaded section. Okay, so the circle is going to be pi r squared. Well, here's the issue. I know that this segment right here is 8, but I do not know what the radius is. The radius is going to be this segment right there. This one. So I know that this is 8. I also know that that portion is 8 also. That's because the 90 degrees is split in half. So we get 45, 45, 90. But just trust me that that little segment is 8. I just said this is 45. This is 45, which we know how, that's why we know that the legs are congruent. They're 8 and 8. So we're going to use a 45, 45, 90 triangle. It goes L, L, L root 2. Now the side across from the 45 is 8, so L is 8, L is 8 again. So L root 2 is going to be 8 root 2. That 8 root 2 is our radius. It's across from the 90. So that now will help us find the area of the circle. So area of the circle is pi r squared, so it's going to be pi times 8 root 2 squared. 8 squared is 64. Root 2 squared is root 4, which is just 2. 2 multiplied by 64 is going to be 128, and then I keep the pi. So 128 pi is our total area. It's the circle. Now we need to find the shaded portion. This is definitely going to be more difficult. So I need to think, what can I do, what can I subtract so that I end up with that shaded portion? What I'm going to do is I'm going to look at this sector. I'm going to find the area of the sector, and then I'm going to subtract the triangle, the big triangle, that is. So let's start with that sector. Hopefully remember that to find the area of a sector, we're going to have to use a proportion. Now our central angle is 90, so I have 90 out of 360 equals the area of the sector is what I'm finding, and then pi r squared, which is 8 root 2 squared. So this ends up being 90 over 360 equals x times, we already found the area of the circle up here in the total. It's going to be 128 pi. And then I'm going to do cross products. After my cross products, I get the area of the sector to be 32 pi. That's just the sector. Now I need to subtract that circle, or the triangle, I mean. Just to be clear, this is the triangle we are talking about. Okay, so a triangle is going to be 1/2 base times height. Now my base is all of this. So it's going to be 8, and then there's another 8 here. So my base is going to be 16, and my height is this segment right here. My height is 8. So what I did is I basically took the triangle and I flipped it so that this portion is the base. So I just looked at it a different way. So half of 16 is 8, so I'm left with 8 times 8. So this becomes 32 pi minus 8 times 8 is 64. Now, 32 pi and 64 are not like terms, so do not combine them. Just leave it like that. I'm still not finished. I need to calculate the probability. So the shaded portion is going to be 32 pi minus 64. And then my total area is 128 pi. Now, in this case, I can actually simplify. In order to simplify this, I need to find out what goes into common into 32, 64, and 128. What are those all divisible by? Well, you might not be able to recognize it right off the bat, but they're all divisible by 32. So you can divide by 32 right out, or just keep dividing by 2 and eventually you would get there. 32 pi divided by 32 is just 1 pi. 64 divided by 32 is 2. 128 pi divided by 32 is going to be 4 pi. So this is our probability. Again, looking at this, I have no idea what this probability actually is as a number. So let's plug that into our calculator and see what we get. Now remember to put that numerator in parentheses. If you don't, you're going to get the wrong answer. Also, remember to put that denominator in parentheses, because if you don't, you're going to get the wrong answer. Now, when I put this in my calculator, I got my answer to be about 0.0908. Okay, first of all, is this a number between 0 and 1? Well, yes, it is. So that's a good sign. Now, it's close to 0, which means that the probability of falling in the shaded region is not very likely at all. Looking at our figure, is that the case? Well, yes, looking at our figure, the shaded region is so small compared to the rest of the figure. So it should be unlikely to fall in the shaded region as compared to the rest of the figure. So that was a way to check our answer. Now, I know this is probably a little overwhelming because we're taking everything that we learned in the area chapter and shoving it into one. But I do have one example that I would like you all to do. Here's the example that you are doing. Calculate the probability that a randomly chosen point in the figure falls in the shaded region. So this is going to take you a few minutes, which is okay. Pause the video and do the best that you can. Good luck. Okay, let's see how we did. So it says, calculate the probability the randomly chosen point in the figure falls in the shaded region. So let's remember that probability is going to be shaded over total. So I always like to start with the total because I think it's easier to calculate the total area. Our total figure in this case is a rectangle. So it's going to be base multiplied by height. The base is 8, the height is 5. So our total area is 40. Bam, easy. The shaded region is a little more difficult. The shaded region in this case is going to be the rectangle, but then we need to subtract that white trapezoid. Hopefully you recognize that as a trapezoid. I know that you're not shown that any sides are parallel, but these sides are parallel because of the right angles. So we're going to have these right angles, then our corresponding angles are congruent, which makes the lines parallel. But I'm going to bet most of you looked at that and just knew it was a trapezoid. So back to the area of the shaded region. We know that our rectangle is 40, we already calculated that. That's the entire figure though. I only want the shaded region, so I need to take out that white part, the trapezoid. Remember that the area of a trapezoid is 1/2 height, base 1 plus base 2. Hopefully you remember that, or you took the time out to look it up. Now the height of our trapezoid is a little bit sideways, but the height is right here. It's the segment connecting the two bases, so our height is 2. Our bases are this right here, which is 3, and this base right here, which is just the side length of the rectangle, which is 5. So I have 40 minus 1/2 and 2 is just 1, and then 3 add 5 is 8. So 40 minus 8 is 32. Okay, so now we're on to calculating our probability. It's going to be shaded, which is 32, over total, which is 40. Please remember that you have to simplify this. So I need to think, what can I divide both 32 and 40 by? Well, I can divide both by 8. 32 divided by 8 is 4. 40 divided by 8 is 5. So my probability is 4 over 5, which is 0.8. 0.8 is really close to 1. So that means that the probability of falling in the shaded region is pretty likely. Well, let's look at our figure. Is it very likely that if we chose any random point in the figure that it would be in the shaded region? Well, yes, it's very likely. The shaded region is a big portion of the figure. So the shaded region is going to have a higher probability. So hopefully you got that answer. If not, that's okay. We do have 2 days of practice for geometric probability. So that's almost the end of the video of what we have done so far. We calculated geometric probability with number lines, and with geometric figures. So the number line, you just looked at what you're interested in over the total number line. Geometric figure, it was the shaded region over the total region. So when you come to class on Monday, we will be doing some examples. Please make sure that you bring any questions you may have. See you on Monday.